Hello and welcome to Datacasts. I haven't done one of these videos for quite a while, but I thought today that I would show you how I go about cleaning ugly Excel data using an R script. Here you can see the Excel file, and I actually took this from the tidyxl YouTube channel. They actually went through this exercise themselves over several episodes. And I kind of started to watch those videos, but I thought, I might try this myself to see how efficiently can I do this, and I want to write as few lines of code as possible in order to get this data into a tidy format. And any of you who work at all with the tidyverse packages will know what I mean by a tidy format. So this is an Excel file that has two tabs, and there's similar things in each tab. So we've got a player and their name and their height, their weight and their age, and that's the information set in the top left. So then down here we've got like an activity or an exercise, if you like, which is sort of merged across three cells. And then we have a date column. So for each date we have the duration, so the time they spent jogging, the distance that they jogged. And then we have another exercise here, which is swimming. And again, we've got the dates and the duration, the time that they spent swimming. And then the other sheet is a kind of similar thing, but we've got different exercises here for a different player. So we've got walking and weightlifting. Again with date, duration, distance, date, duration. So I want to get this into a tidy format. So if I switch over to RStudio, I have already written the code and I want to talk through what it is that I've done. I'm going to show you the end result, which is this. So we've gone from this to this using this code. So I'm just going to talk through what I did, and there's three packages that I've used to do this, and a big revelation for me as I did this was not to use the readxl package. So if we switch over here to the tidyxl guys code, they've used the readxl package, and I did as well to begin with, and I realized that that was a mistake. Or rather, it's a lot easier if you don't use the readxl package, and this was a huge revelation for me. So when you get a file, an Excel file, it comes in there's two different flavors of Excel files. So there's this type of Excel file where somebody has arranged the data in the sheet in a way that sort of visually makes sense to that person, but from like a clean data perspective is obviously a bit of a nightmare. And then there are other sorts of Excel files where you open it and it kind of looks like a normal table. It's just that maybe we need to do a bit of work on formatting some of the columns or clean up some of the column headings or pivots, things like that, right? But when you read the file, it's already in a kind of a tabular format. This is not in a tabular format. In this case, we have kind of like multiple tables that are arranged across different areas of the sheet. So it's not even in a table to begin with. And in that situation, using the tidyxl package makes a lot more sense. Why does it make a lot more sense? Well, if I just switch over to the GitHub page for tidyxl. So it describes itself as it imports non-tabular data from Excel files into R. It exposes cell content, position, formatting, and comments in a tidy structure for further manipulation. This is the key thing. Is it exposes cell content. It doesn't try to give you a table. It reads each individual cell and gives you information about each individual cell. So if I come back to my code, so I'm just going to clear everything out because I've already got a bunch of things stored there. So now my environment is empty. So I'm loading tidyverse because we obviously always load tidyverse. I'm loading lubridate because I am working with dates. And then I've got the tidyxl package. Now I have this functions file, so I wanted to get this to under 50 lines of code to do this. I'm kind of cheating a bit really, because even though this main file is under 50 lines of code, I do have a separate functions file where I've stored some functions. But hey ho, I mean technically some of the things that we're pulling from these packages are functions, but we don't kind of write them all out. So sort of cheating, but sort of not. And I'm only using two functions, and as you can see, they're quite small functions, and I will talk about them when we get to them. So I load in that functions file so I can use those functions, and then I read the Excel data using the tidyxl function xlsx cells. And this is the thing that will help me to describe the cells. Now, if I just run this, if I just pull in the functions. I'm just going to run xlsx cells and assign it to raw data. So I've got my raw data variable. If I open this, this is what we get with that package. Now I think this is really cool in situations where what we're getting in Excel is really not a table in the first place. It's just data scattered all over the place, which is what we have with this ugly Excel file. So it's just data that's scattered everywhere. And I need to understand where that data is situated in this spreadsheet. That's what this is doing. So wherever there is data in the spreadsheet, it will describe it for me. So first of all, we've got the name of the sheet. So this is our first sheet, 1, 2, 3, 4, 5. And it's saying in address A1, which is row 1, column 1, it's is blank false because there's information in there. It's trying to tell me what data type it thinks that is in that cell. So if we look at A1, that's this one here, the one that says player number. So it thinks that's a character, which it is. No errors, it's not illogical, it's not numeric, it's not data, it's character. And then it's given me the data in that, what it thinks is a character field, which is player number. This is sort of the key information for me. There's a whole bunch of other stuff around like formatting and the width of the cell and the height and all that kind of stuff. I'm not really interested in that. What I'm interested in is really just a few columns here. The sheet name, we can see that we have the 1, 2, 3, 4, 5, and then further down we have the 1, 3, 2, 4, 6 for that second sheet. So the sheet name. The address is kind of interesting. So like in an Excel format, we have A1, B1, A2, and so on. But the thing that I find useful as I go through is the row and the column. So row 1, column 1, the address of which is A1. This has a character type, character data type, and the value there is player number. And then we can carry on and look at some other ones. So let's look at B2. So row 2, column 2. So B2 is this one here with the 187, which equates to the height in centimeters. So B2, it's identified this as numeric, and then it's popped that value into this numeric column. So this is really useful information that I can now use and manipulate to create the tidy format table that I want. So let's get started with that. First of all, I want to get the names of the activities. So what I'm going to do here is pull out the key information. So there are these activity names, there's the player's name, the player's height, the player's weight, the player's age, and then for each activity we have a series of dates, durations, and distances. That's it. That's all we've got here. The player's name, the height, the weight, the age, the player's ID, which is in the name of the sheet, and then an activity name, and for each activity, date, duration, distance. This is the information that I want to grab from here. So first of all, the activity name. Read the raw data file, which I've done here. And remember, raw data is not reading the Excel file as a table. It is information about each cell that I'm looking at. So what I want to do is I want to filter this information to get row 6, where the row equals 6. If we switch back to here, so row 6 is this row. Okay, this is where the activity names are stored. It's an assumption I'm making that if there were more sheets, that the names of the activities would always be in row 6, because they're in row 6 here and they're in row 6 here. So this is the row that I want. So get row 6 and then look for anything where there is something in the character field. So if I come back here and look at, so this is row 6 is this bit here, and then the character field. So there's information here and there's information here. That's what I'm going to grab, and I'm just disregard anything where there is nothing. Because these have been merged across multiple cells, they actually live in, walk in here lives in A6, and weightlifting lives in D6, whereas B6, C6, and E6 actually doesn't contain any data because it's been merged. So if I were to unmerge this, which I think is what that does, see it places it here in A6. So this is what I'm filtering to get. Everything in row 6, but just those cells where there is actually data. And then I don't want all of these columns. There's just a few that I need from here on in. I just want the name of the sheet, the column number, and then I want what is in that character column, but I'm going to call it activity name. Now if I run this, and then I open up my activity names variable, this is what I've got. So for the first sheet, which is the 1, 2, 3, 4, 5, column 1, jogging, column 4, swimming, and then the next sheet, 1, 3, 2, 4, 6, column 1, walking, column 4, weightlifting. Now I'm basically going to do something fairly similar for all of the rest of the information that I want, and then I'm going to join everything together. So let's go through that. I've got the activity names. Let's move on and now get the duration. So the duration is here and it's here. So again, let's think about the location of this. It is in the second column and it is in the third, fourth, fifth column. The second column and the fifth column. And the actual data is after the 7th row. I don't always know how many duration rows that are going to be, because here we've got this many, and then here we've got more. So I don't know how many rows they're going to be, but I know that they will be after the 7th row. So they'll be from the 8th row onwards in columns 2 and in columns 5. So let's look at this. So if I want the duration, get the row data, and then we've got this. So this is my function. I've called it find activity stats, and I've passed 2 and 5. So these are the column numbers that I'm interested in. Remember, 2 and 5. So what is this doing? Let's switch over to the function and have a look. So find activity stat. I've described this as filter based on either of 2 column numbers supplied to get activity data, and then select standard fields. So I'm passing the data frame, which is all that raw data, and then I'm passing 2 column references. So I'm saying data frame, filter, column equals the first column I've passed or the second column that I've passed. So for those of you who are not familiar with what's going on with the double curly braces here, this is, I think, maybe fairly newly implemented via the glue function. So if you want to use a function and then pass variables and then call different dplyr verbs, you can do that with these. I'm still kind of learning it myself. I only started using this recently, but it's really cool because I'm kind of doing the same thing over and over. As I start to grab the date and the distance and the duration, I'm going to do a fairly similar thing. All that's changing as I do this is I'm going to be calling different column references, but everything else is the same. So for the distance, I'm calling 2 and 5, which is that one and that one. And then if I wanted to call the date, that would be 1, 2, 3, and 4. 1 and 4. So the next time I call this, I would pass 1 and 4. And then the thing that's constant about the row is always going to be after the 7th row. So it's always going to be after this. And then I just want to select certain columns that I'm interested in. So I want to get the sheet column, the columns from row to column. So if I look here, row, column, and numeric to character. So that is numeric, date, character. So it'll be sheet, row, column, numeric, date, character. And the reason I'm grabbing all 3 of these, numeric, date, and character, is because the data could be in any 3 of these in some situations. Because this is messy data, sometimes it looks like numeric, sometimes it looks like date, sometimes it looks like character, particularly for duration. So duration sometimes comes through in the date column. So you see this here, 1899, 1231. This is actually duration, but it's been read as a date. Other times the duration could be in character. So here, this is duration, and it's come through in character. And sometimes it comes through in numeric. So I think that's what this might be here. And how do I know which is which? Well, it's because I'm filtering on where it should be located. So it's always going to be in a row that is greater than 7. So from this point onwards. And I'm specifying which columns. So for duration, I'm saying it's going to be in columns 2 or columns 5. So if I look back here in row data, so column 2, yep, this is a duration. Column 5, this is duration. Here it happens to be numeric. And if I switch back to the Excel file, come back to this first one here. So we've got 1:05, which is, I assume that's an hour and 5 minutes, and then 0:45. So here's the 1:05, and then here's the 45. So that's what this function is doing. It's filtering down to the relevant columns and rows, and it's just selecting the columns that I want from raw data. Now, if I just run that just to show you what we get back. So any data in the numeric or the date or the character columns now, I know these are durations. This is a duration. This is a duration. This is a duration. This is a duration. Now I just need to format this accordingly. So this is what we call mutate. The first thing I'm going to do is I'm going to change the column and deduct 1 from the column number. Now, why am I doing that? The reason I'm doing that is because at this point, now that I've got the information I need from the relevant columns, I want to make sure that the column numbers align with the column numbers for activity names, because I'm going to use that as like an ID to join everything back to activity names. This will all make sense when we start to join. And the activity name columns, if you look at activity names again, they are 1 and 4. So the first activity has essentially an ID of 1, and the second activity has an ID of 4. This is what I'm doing here. Because my columns are 2 and 5, I need to deduct 1 to get 1 and 4. Then I'm actually creating this duration column by formatting what is in either date or character or numeric. So I'm calling a case when. I'm saying when there is something in the date column, so when it is not NA, the exclamation mark is saying it is not NA. So if we look at down the terminal again, so this first row here, that condition is true. There is something in the date column. What I want is this piece that is in sort of light grey here. This is the duration. This date is just something that's been added in because when tidyxl read this, it thought it was a date, so it's added this date. I don't want that date. I just want this second piece. Now, if you think of this as 2 words, this is the first word and this is the second word, well, then we can use the string_r package and just grab the second word. So that's what this is doing. If there's something in the date field, then call the word function on date, grab the second word. And that's just going to pull this, which is what I want. Then we switch to the character column. So we see down here in character, we do have what we know is a duration. So again, if there's something in the character column, then we are going to call paste. So we just need to fix this. If there's something in the character column, that means that something like this has been written. We've got :50. So someone has just added in the minutes and it's been read as a character. So we just need to flesh that out. So first of all, we paste in the 00. So this stands in for the hours. Then we pull in the character itself, which in this case is the :50. So that stands in for the minutes. And then we add in our seconds. Again, 00. So with the case of this :50, it would be 00, :50, :00. And then finally, we look to see, is there anything in the numeric column? And we can see there are several of those in numeric. Now, these are all durations. And again, these are the minutes. So if a colon is placed in front of these, then they get read as characters. And that's this situation. If there's no colon in front of them, they get read as numeric. And that's what we get here. If we switch back to the Excel file, we can see what this looks like. We have a colon here, so this is a character. But these durations for swimming, there are no colons. So they've been read as numeric. And we're assuming here that this refers to minutes. So if there's something in your numeric column, we just call paste again. We're doing exactly the same thing. We're just putting 00, and this time we need to add a colon as well because there's no colon included in the numeric. And then we put another 00 with a colon. So again, we're just fleshing that thing out. And then we call .keep equals unused. This is also something I learned about recently. If you're running mutate in a bunch of columns and then you don't need those columns afterwards, then you can just say .keep unused, which is saying only keep the columns that I've not used in this mutate function. So it's going to drop date, character, and numeric because I don't need them anymore. I'm just going to run this. And then let's have a look at the duration variable that we just created. And here we go. We've now got the sheet, the row, the column, and then these nicely formatted durations. So now we've got the duration. Next, we're going to get the date. So we can call raw data, call that find activity stat again, and it's 1 and 4. Columns 1 and 4 is where it's located. So that's 1, 1, 2, 3, 4. And then we call mutate. So we don't need to adjust the column number here. So remember up here, we adjusted the column number to align with the activity name. We don't need to do that here because the date column is situated in the same column number as the activity name. So jogging is in the A or number 1 column, and swimming is in D or the number 4 column. So these will already align. So we can jump straight into creating this date column, or rather we're kind of reappropriating the existing date column. We're calling the case when again, and we're looking at date. Before I do this, let's just run this the first 2 lines so we can see what we're working with. So here we go. Okay, so is there anything in the date column? That's looking at this here. If there is, then we just call the lubridate as date and just format it as date. In this case, it's formatted as date time. We don't want the time, we just want the date. So that's all that's doing. But sometimes the date comes through in character. What I'm going to do is I'm just going to run that again, and then I'm going to go with a view so we can look at the full thing. So you can see most of the time the date is in date, but sometimes it comes through in character. Yeah, I think it might be examples like this. You see we got the slightly odd looking date, and this is coming through as a character, where instead of having the year and the month and the day, we've got the month, the day, and the year read as a character. So we need to account for these slightly rarer situations. It only happens twice. This is why we're pulling through numeric date and character, because our actual data could be read as any of these. So we formatted it when it comes through as a date, and when it comes through as a character. So if there's something in the character field, we're saying, again, we're calling the lubridate function MDY, month, day, year, because that's how this is coming through. We've got the month, then the day, then the year, and then we'll get a nicely formatted date from that. And then finally, I'm saying, I'm just calling something on numeric. I'm saying if numeric is NA, then put NA, the date type of NA in there. This isn't actually doing anything because all of my dates are either in the date column or the character column, so everything's already accounted for. The only reason I'm doing this is because when I call keep unused, I want to make sure that I'm actually using numeric so that it gets dropped. What I don't want to do is run mutate on the date and the character and then say keep equals unused, and then I have to select and deselect numeric. So by adding this line into the mutate, I can get rid of it afterwards through this. So if I just run the whole thing, and then you'll see what this looks like. So now I've got my date variable. So I've got sheet, row, column, and the nicely formatted date, in the same way that I had sheet, row, column, and the nicely formatted duration. So we're making really good progress here. And then we come on to distance. So we've got distance here, and we only have distance once, and we may have it here. I wanted to assume that we may have it for the second exercise or the second activity, even though we don't. So I've said for distance, again, we've got a find activity stat function, and then we say it could be in column 3 or it could be in column 6. Even though there's nothing in column 6, I just wanted to kind of allow for that possibility, but there's definitely things in column 3. And then we run mutate, and this is much simpler. So we do need to adjust the column number. So this time we need to decrease it by 2 so that it's equal to 1 and 4 rather than 3 and 6, so that we can align this later. Now, if I just run the first 2 lines, this is actually pretty straightforward. All of the distance numbers are in the numeric column. So I don't need to do anything further here other than just to say that we're creating a new column called distance, and we're just going to pass whatever is in the numeric column. And I can't do dot keep unused because on this mutate we're not using everything. So in this case I have gone for a select, and I've said just give me sheet to column, so the first 3 columns, and then distance, which is this new one that we've created. So if I run this, and then we've got our distance variable, again sheet, row, column, and then the distance. That's great. So now we kind of have everything that we need from the activity. We've got the activity name, we've got the date, the duration, and the distance stored across these different variables. Now I want to bring all of that together. So I'm creating a new variable called activity data, and I'm going to start joining things. So I'm going to do a left join. I'm going to pass the activity names, which is the one that we had up here. If we just remind ourselves of what that looks like, activity names. And I want to join that on duration. So it's activity names and duration that we're joining. How are we going to join this? Well, we've got two different sheets, so we want to make sure that we're joining on the correct sheet. So we'll join by sheet. We've got a sheet here, and we've got a sheet here. So we want to make sure that we've got that joined. And we also want to join on column. This is why we were adjusting the column values here. So column number 1 is whatever the first activity was in each sheet. So if I join by PID 1, 2, 3, 4, 5, column 1, then that will be jogging. If I join by PID 1, 3, 2, 4, 6, column 4, so this row, for example, here, where we've got 80 minutes, that refers to weightlifting. So I'm left join activity names, duration by sheet and column. Now if I run this line, you can see the join. We've got the sheet, the column, the activity name, the row, the duration. And I can check this. So here's jogging, where we've got 105, 45, 130, 110 and 50. Jogging 105, 045, 130, 110, 50. Brilliant. But we also need the date and the distance. So we're going to join again by date, but this time we need to join by sheet, column and row. Why row as well? Well, when we were joining activity name and duration, we were only joining by one thing. But now we need to make sure that our durations align with the correct dates. So we're not just aligning with what is above, we're also aligning with what is next to it. So I want to make sure that I'm joining on the sheet, on the column, and then row 8 here, 105, now that should match a specific date. If I look at my date variable, row 8, that's this one, the 1st of October 2021. And column 1 is the first activity on that row. So let's run both of these two lines and let's see what happens. Now we've got the date and we can see that these dates are correct. So we've got jogging on the 1st of October 105. Jogging 1st of October 105, that looks good. And the 2nd of October for jogging should be 45 minutes. We've got the 2nd of October and it is 45 minutes for jogging. So this looks great. And then we can just repeat this one last time for the distance. Left join on the distance, again by sheet, column, row. If I run all of that, then I get the activity data. If I open up this new variable activity data, here we go. In this sheet, we've got this activity, and on this date, this was the duration, here's the distance. Sometimes we don't have a distance, so for swimming, for example, we only have duration and not distance. And we can see that here, we've got duration, but there's no distance. All right, we're most of the way there already. We've got all of the activity data. This is what we've been doing at this point. We've been building up the individual components of these activities and then bringing them all together into one activity table. Now I just need to grab the player data. So I create a new variable called player name, pulling in the raw data again. Now, where is the player name? The player name is here. It's in the second column, in the first row. So I say row number 1, column number 2. And then I want to select the sheet, the player name, which is equal to character. So if I look at row data, so column number 2 and row 1, here in the character column is the player name. This is what I want to grab. And then further down, we've got another player name, Peter Mills, which again is in row number 1, column 2. So I want to get this. I'm just very specifically identifying this is the cell that I want from each sheet. So if I run this, let's take a peek at the player name variable we just created, and here we go. It's quite straightforward. In this sheet, here's the player name. In this sheet, here's the player name. And we're done. Then I want to get the player data. Here I'm using map2. It took me a little while to figure out how to do this. I wanted to make this as efficient as possible. So I've created another function. So where previously we had find activity stat, I've created another function called find player stat. So here's the find player stat function. So this is saying filter based on either of two column numbers supplied to get player data, select standard fields. It's doing something very similar to find activity stat. So we're passing in a row and we're passing in a stat name because there are different player stats Remember, we've got height, weight, and age. So it's passing in row data and it's saying filter to a row number that I supply in column 2. So the stats will always be in the B column in column 2, but each stat is on a different row. And then select the sheet column, the stat name, which is the numeric column. So I'm pulling in the numeric column, which is where the stats are going to be found, but I'm just renaming it to something, and I'm going to pass that name into this function. Again, we're using this glue syntax to do this with these double curly braces and this colon equals sign. Okay, I want to call that function for each of the player stats. What I don't want to do is to write out on each line a call of that function. I did that originally and it looked ugly. This is where map2 can help us. It will repeat over a set of variables and pass them to a function. And you can pass 2 variables as long as they're the same length. So my first set of variables, it's a list, but I pass 2, 3, and 4. Why 2, 3, and 4? Well, this is the first argument that's going to go to the function. Let's look again at the function. What's the first argument? It's the row number. What are the rows that I want? 2, 3, and 4. And then the second argument is the names of the different stats that I'm pulling. So which stat is in the second row? That's player height. We can see that here. Player height. And then the third row is player weight. Player weight. So this matches to this, and this matches to this, and then the fourth row is player age. Player age. So what map2 is going to do is going to call the find player stat function that we created. It's going to pass a pair of arguments from each of these lists. So it's going to pass this 2 along with player height. So it'll call the function and then it'll say row data filter row equals 2 and column equals 2. So row 2 column 2 is 187. This is the height. And then we'll select sheet and we'll select the numeric column where the data is located and we'll name it stat name. And the stat name we passed, player height. Then we do the same thing. 3 player weight, 4 player age. I'm just going to run this one line and hopefully I've run everything correctly up to now. Yep, here we go. We get 3 tibbles. The first one is our player height with those values. We've pulled in the sheet name. And then we get the player weight with the values, the sheet names. And then the player age, the values, and the sheet names. Because these are 3 separate tibbles, I want to join them all together, and I can do that based on the common field, which is the sheet. So I pass these tibbles into the join all function from the plier package, and I'm joining on sheet. So if I do that, now we have this one table, the sheet, player height, player weight, player aged. Perfect. There's one thing missing from this, which is the player name. So we'll just do a separate left join on player name. And again, if we look at player name, the common field here again is sheet. So the 1, 2, 3, 4, 5, that's Aaron Jacob. And then the next one, that's Peter Mills. So I'm going to run that whole thing. And then I'm going to look at player data, which is the variable we just created. And here we go. The sheet, the player height, the player weight, the player age, the player name. We're done. So we got all of our player data in just these few lines. I mean, it's technically just 6 lines. So there's one last thing to do. We've got our player data and we've got our activity data. We now need to join our player data with our activity data. Again, really simple. Do a left join, pass the player data and the activity data. And what's the common field between these two? It's the sheet. So we join by sheet. Let's take a look at that. And here we go. So this sheet, the 1, 2, 3, 4, 5, that is Aaron Jacob. Here are his stats. Here is activities and the associated stats for those activities. For one final piece of cleanup, there's certain things I want to select. Sheet, this is I kind of saw this as a player ID field. So I'm just going to rename the sheet to player ID. I want the player name after the player ID. So I first get player ID, then player name, then everything else. And I no longer need the row and column references, so I can remove them. So if I run that, open clean data, and here we go, we're done. So this is a fairly efficient way of doing it, I think. Some things I learned, as I said before, using tidyxl. If your data in their Excel spreadsheet is not in a tabular format, it's just kind of arranged across the spreadsheet, use tidyxl. Because having that represented in this way allows you to very easily identify the data that you need. You're not trying to force it into a table when it doesn't come as a table. You can instead have each cell described to you and locate what you need accordingly. The other thing I learned with the functions is using this glue format. So if I want to run the same function over and over again, and I'm using these dply verbs, then this is quite a neat way of doing it, just to save yourself some lines of code. And the final thing that makes this quite efficient is running map2, because if I'm doing the same thing over and over again, I'm passing 2 arguments to the same function, and I'm just kind of rerunning that function across those arguments. As long as those arguments are the same length, so the 2, 3, 4 on the player height, player weight, player age, then I can just run map2, and it'll do all that for me, return a bunch of tuples that I can then join together using a common field. So I hope you find this useful. I just want to thank the tidyx guys for supplying the spreadsheet. This is a really good opportunity to learn some new techniques, and I'm quite pleased with the end result. I'll put this up on the Datacast GitHub if anybody else wants to use this code or inspect this code. If anybody has a different way of doing this, or if you think that I can make this more efficient, then let me know. I'd be really happy to hear that. If you enjoyed this video, give it a like, please subscribe. Thanks for watching, and I'll see you guys soon.